Can you guys see me?
Yes.
Oh, cool. Okay. All right. That's great.
I have a quick question.
Yeah, sure. Hey, hang on. Hey, that's much better. Yeah. In fact, I don't need that light. I think I mentioned this last class. Yeah. Just
When is it says the midterm is due in December, but is that correct?
it says the midterm is due in December.
Yeah.
Okay. I'm trying to think what I was thinking when I did that. So I wanted to give you guys 2 chances at midterm, I think. One now and one in December. Unless you guys don't want it. Okay. I can.
It's okay.
We will be grateful.
All right, let me take a look. Actually, if I look at the page, I'm pretty sure I'll remember. Okay. So midterm exam available until December, 60 minutes, attempts 2. All right, so it says 2 attempts, but why does it say it's yeah, okay, I think that's what I did. Okay, so it opens on it opens next week. Yes, it opens next week, right? You can't take it before then.
Hello, Professor.
When is the first? When does it open? Available from? Is it open already?
Yeah, it's open already.
Okay, all right, good. When did it open, by the way? I thought I made it open in weeks.
Yeah, and the quiz first. The quiz first is due December. Both due December. The quiz first.
Yeah, it was open from day 1, apparently, the midterm.
So was it? I tried to look at it.
I didn't set a starting date. But that's good. You shouldn't take it before. You shouldn't take it before next week, because
okay.
So I think we'll leave it like this. Okay, so this is going to be my grand experiment. For maybe if this works out, I can adopt the strategy next quarter and going forward is to give you all 2 tries at the midterm, and they will both be open from day 1.
Okay.
Well, not the final. Well, actually, I suppose I could open the final also on day 1, but you only get 1 chance at the final, but you get 2 chances at the midterm. And you just have to be, I don't know. Yeah, well, you guys have to send me feedback, okay? Because if you want it or not, because some students may not want it, because if you have these wide open midterms, although it's open book and everything, they may feel that the grade or the score you get in it doesn't really matter, because there will always be students who would take it one time and then remember the questions or write it down and pass it on to someone who takes it later. We just opening up the field, and so many students may feel that the score they receive is not meaningful anymore if we do that. Okay, so if that is important to you, send me private email. Okay, you don't have to speak up now. Just send me email, and depending on what I hear, I can change it. Or if you have suggestions also, that's fine. I can do that. Oh, one thing I can do is to open it one day in week 6 and another day in week 12, so that you can take it one more time in week 12 on one of those days, right? You just can't take it anytime you want. I think that's much better. Yeah, then that's much less scope for the score becoming meaningless. Then you can take
both are fine for
on
me.
Thursday, right? You can take it on Thursday, but if you're not happy with the score, then you can be assured that you get one more chance, but only one more chance, and that will be in week 12. And also, that is one of the situations you don't want to find yourself in, right? Because before the final, you want to be focusing on other things, wrapping up your class, polishing up points, and going to earlier class and getting those 1 or 2 points that you missed before after you got the password and moved on. So those are things that you'll find to be much more fun towards week 11 and 12 than saying, oh, now I got 2 C++ exams to study for, because I want to do the midterm again, right? Or maybe I skipped the first one, or I did very badly on the first one, because I knew I was going to take it again. So that was my main reluctance before for saying there's only one crack at the midterm. But if you guys are okay, I'll change it today to say that you get 2 cracks at the midterm, one next week. Okay, that I think it's on Thursday. Yeah, so it'll be Thursday, but anytime Thursday you can take, right? So from I think 6 a.m. until midnight. But once you start taking it, you can pause it and you can go and come back. So it's just 60 minutes. Once you started, it's 60 minutes. It's the usual thing, right? Just like your quizzes and everything else.
Also, on the data representation quiz, the description says you have 1 attempt, but you're allowed 2 attempts from Canada.
There should be 2.
2 attempts, okay.
Where does it say 1 attempt? Oh, I see in the description. In the description. Yeah, I think I just need to change it. You know, that's just I changed a text type, forgot to change maybe. That's inside of the quiz. That's why I forgot. When did you say, is that also like the midterm, like just generally open until the end, or is it?
Yes.
Open? It's just open?
Yeah.
Okay. I think data representation is okay, right? So giving you 2 attempts, open the first time, and then you can take it any one more time, but you can wait until but my recommendation always is to finish up these things, right? You got to finish up these things when you have a chance. And then you can save the later part of the course to savor the really fun stuff, right? And also focus on the final, right? So the final I think is is heavier than the midterm, right? So I think the midterm is only 20 and the final is 40, and they add up to 60 and get scaled down to 25. But still, the proportions should hold, right? So the final is twice as important as the midterm in terms of points.
Anand, I haven't taken any of your C++ exams before, so I'm just a little curious.
No, it's exactly like it's like the data representation quiz.
Oh, okay. So,
Yeah.
do you have like, hey, just to prepare for it, make sure you know the materials between like this chapter and this chapter, or anything like that? Like, what do you want us to take away from this first half of the class?
For the midterm, you just need to be very, very comfortable with the mechanics of C++, the control structures, right? For loops, statements, and then you need to know things like, and you need to be able to run basic, simple code in your head. That's all, right? Once you know how the basic mechanics work, you can just run simple code in your head, and in your midterm, you may have fragments of code, right? Like 5 lines.
Okay, and just the standard library.
Yeah.
Okay.
Like a while loop or something like that, do while loop or something, right? And I don't think either in the midterm or final, even in CS2C, right? You don't get given like 20 lines of code, bam, like that, and say, here's an algorithm, right? Find out something about it. I don't think that happens in the midterm or final, right? So you have to do that, a lot of that in the quests, but not in the midterm.
Okay. That sounds good. Oh, so there is no overlap between quests and the midterm. It's just really focused more so on the language itself.
On the concepts.
Got it. Okay, that makes sense. Thank you.
And I think the exams exams and quizzes are designed to test your concepts so that you can, once you do the exams and quizzes, you can be confident that, okay, now I know what's going on. And then my intention is that the quests give you a chance to exercise those concepts and say, well, you know what, I learned that, if I did that, it would be faster. So let me try that here in this quest in Fibonacci and see if it actually works, because Fibonacci needs to be fast in order to complete. Otherwise, you don't get those last 2 trophies, right? You get the password, but you don't get the last 2 trophies, the last 2 or 4. I don't know. I forgot how many they are. But so those kinds of things. So I don't know. Sometimes when I'm bored, I take a look at some of the log files in the question system. And, every time I see a lot of people trying to hack into the system. And so, strangely enough, and strangely
like
enough,
the actual system
into the question system, right? But people from around the world and other countries, they try to hack in to anything that's open, right? So that's fine. But the thing that's really curious that I found was a few times, not this quarter maybe, maybe this quarter, I don't know, because I haven't looked closely, but I think in a previous quarter I looked, and it was actually enrolled students who were trying to hack in, but these were in 2B, not 2A, right? So 2B. A lot of students tried to hack into the system, and it's just enrolled students trying to hack in. And that's kind of cool, right? Because, it shows that you're curious and inquisitive, but, but the intent is important, right? So, I'm trying to hack in to find out how it's all done. That's really cool, right? But trying to hack in to see if I can beat the scores or, get something from it, or, do the quest without having to actually do it. Yeah, that's no good. In fact, the strange thing is, if people, I know there are people who are trying to hack into the system, trying to figure out how it works so they can do something similar. But even if they hack in, that system only takes like a couple of weeks to put together, right? So there's no value in the system itself. What I realized later on myself is that, even though I just created the question system as practice, the history of the question system is actually very strange, because the very first one that was put together was 2B's first quest. That is equivalent to your 2A ninth quest, right? In the ninth quest of 2A, you have to deal with pointers, right? Which is really the crown of C++, right? And it is so cool. And a lot of people just give up before going to quest number 9. They do up to quest 8, and that's enough, right? If you do quest 6, you pass the course. And a lot of people give up, and that's a pity, right? You have to get to quest 9 because 2A means that, you know how pointers work. You have a firm intuition about pointers in C++, which really is one of the most salient distinguishing features of C++ compared to all these other languages, right? Where you can have this explicit distinction between data types. And and so one time, I think back in 2018, I think, when Debbie, who's now Dean of Fine Arts, right? She took over as acting dean in our division. And then we were puzzling over, why there's such a poor performance in our, follow on. Many students who do our 2A seem to, go off, right? So we tried to do a study, right? So Debbie said, let's be scientific about this thing, right? Let's gather data and let's do some surveys and things like that. And so we looked at the data, and we found that a lot of students who were doing 2A just, go away. So as we started trying to brainstorm ways in which, why are students going away? Why aren't they able to, get into 2B? Or why is the performance in 2B so bad, right? So if the people who come in from outside into 2B, our 2B class are still filling, but they're not our students, right? Many of them coming from outside, and the performance was bad. And so we try to figure out why it's bad, right? Because, they're all the instructors stick to the course description laid out by the state. So I said, well, you know what? Let's try and make a entry test, a free entry test for everyone, right? And put it on the web, on our department website. And just make it known to all 2B students who want to enroll in CS2B. You're free to enroll in 2B, but if you want to be successful in 2B, just try this, program online that we put up, right? And then if you feel comfortable working on that program, then you'll feel comfortable in 2B. So that was our intent, right? So I said, let me try and put something together. And so I put together this quest called Duck, right? And it had no resemblance. Well, it has a slight resemblance, right? So Duck, and I put it online, and some 2B students tried it. And I thought, that's really cool. And the students who did it really like it. So let me try and do the entire 2A series as quests. So that summer, I did 2A and 1A as quests. And one of our senior students actually, gave it a dry run, right? And ever since then, there have been so many little changes and mods and modifications, thanks to students like you, right? To all these quests. Even the wording of the quests themselves have changed. And so much so that I find that the real value of the questing system is not the system, right? That's like 2 weeks effort, right? But the specs and the Reddit forum have now emerged as really the truly valuable points of the questing system, because the specs are really, I think, even if I go back and read my own specs, they're actually fun to read sometimes. And some of the problems posed and some of the questions that are in there are fun for me to think about too, because many times I actually forget. When I'm writing the quest, I have a thought and I say, what do you think would happen if you do that, right? And then I know at the time I wrote the quest, I know that, and then I write that and finish it and I move on to other things. And I go back and read one of the previous specs, and there's a question I asked, and I don't know the answer myself, and I have to think about it and say, well, that's why I asked the question, right? And so it's actually fun to me too. So I think that's really where the value is in the questing system. So, people who hack it, they'll probably save like 2 weeks of work for themselves. But instead, if they just do the quests and then create some other fun quests of their own, right? Because ultimately it just boils down to coming up with a nice little, if you pick up a leak code problem. So there's so many leak code problems, right? Pick up a leak code problem and then weave a story around it, right? Weave a story around it and then set it up so that, set up your own tests so that, the test will fire and you give out trophies, right? Trophies for people to do. So that would I think you find it a whole lot more fulfilling and satisfying, and also instructive, I think, and interesting. And hopefully, if you've got something really, really interesting, right, that'll help you polish it up, and maybe we'll add some graphics to it, and maybe actually make that a quest, right? Not in part of 2A, 2B, 2C, but we have other quests that are not part of 2A, 2B, 2C, and some of you would have found out, right? So like Curiouser and Curiouser, right? That was actually a quest that came out of a discussion between me and one of our past students in a 2A recorded YouTube 2A lecture. If you actually go back to some of our YouTube videos, you'll see, right? So we were talking about a problem and we thought it's so interesting, we'll just turn it into a quest. And that's how that quest was born, right? So there's a bunch of quests like that. So you create one, right? And then we'll just put it up on the question system and advertise it on our Reddit, and people can come and play with it, right? And it'll all be fun. Right. I think, and the thing is, these things are so cheap these days that we don't really need to make money off any of these things, right? In fact, making money of these things is more of a bother, right? Because it'll take away a lot of your cycles when you can just spend having fun with the system, right? Because, once you, this is what I find, right? So many times when you develop a product, the financial roadmap and the product roadmap are very closely aligned during the initial stages. But at some point, we'll find that there is a slight bifurcation at the very least, right? So that the finance trajectory will want you to go one place, whereas a product trajectory will want you to go slightly another place, right? So, and then compromises have to be made, and that's no fun. That's the place that's no fun. And so I don't know how we got started talking about that, but I think, I don't know how we got started talking about that. But yeah, if you that's right. So yeah, as long as we don't focus on, during these, as long as you say we don't need to make any, money out of these quests, right? So it's for fun. It's like a pastime, right? We can just go ahead and do these things. Yeah, it doesn't even have to be on the questing site, right? So I can show you how to put up it doesn't have to go through even the usual questing process. I'll show you how to do something like lead code, right? So I just submit it and it'll run the, and return the results at some point, not during CS2A's quarter. I think maybe over the Christmas break. We'll see. What time is it? All right, it's about 8:20. Well, you know what? Why don't we start at 8:30? You guys should feel free to talk until then. We'll give people, I don't know if any more people are going to join, but if they do, 8:30, we can start coding at 8:30. What do you guys want to do? Right? I'm happy to do anything you want. I'm happy to talk. I'm happy to take your code that you wrote last. I keep saying last week because the days are changing so quickly. Right now, it's still quite dark now. It's right. Yeah. So Tuesday, what did you guys write on Tuesday? Functions. Yeah. Passing parameters by value and so on. Right. So we can take that code. Refactor it, hack it. If you want, okay, refactor and hack it as you guys dictate, right? So, and you can say, I want to do it in a particular way, right? And then we'll try and do it a particular way, right? So maybe you say, no, I want to do it with a do while loop, right? Someone else says, and then Wesley says, no, I want to do it with a while loop, right? So we'll do both ways, whatever, right? So, and we'll do, in comments. But we'll make sure that everything is commented well so that people can. In fact, I don't have to do it, right? I could say, well, we're going to do now. Wesley wants to do it with a do while, right? So we'll just say put a comment there saying now Wesley's typing in the do while way of doing this, right? So we'll say, hey, Lei, go on, right? Go ahead and code that part, and you're gonna do that, and then we'll say, all right, next, a comment, create a new comment. Say Agnes wants to try, a function that takes a parameter by value and another parameter by reference, or something like that, right? So another thing.
Yes, sir. I have a question.
Yeah, go ahead, Alexandria.
So we're using size t everywhere. Why do we use size t instead of unsigned int?
Yeah, I think size t. Well, first of all, there is a distinction, believe it or not, between int and long. Okay, now I think they're both 4 bytes. I think on most architectures, long and int are both 4 bytes long. I might be mistaken, but you can check. But until quite recently, like a couple of years ago, right? I think ints were only 2 bytes. Maybe 10 years ago, right? Ints are only 2 bytes, and longs were 4 bytes. Now, size t is actually unsigned long, not unsigned int. Now, I think it's called unsigned int now because ints and longs are being used pretty loosely, interchangeably by most people, right? Because I think they're the same size now. But previously, I think also unsigned long. I don't know, why did they call? Yeah. I think unsigned long could be many things, right? Unsigned long could be a temperature. Well, not a temperature. Unsigned long could be many things, but a size is always positive. A size cannot be negative, right? Size could be negative. No, a size has to be non-negative, right? It can never be negative. A size can never be negative, I think. Can a size be negative? Well, it depends on convention, I guess. But modern convention, we accept that size cannot be negative. That's why I think, in fact, size t is not a native type. It's not a native type. The compiler doesn't understand size. I don't know if the compiler understands size t. Maybe it's size t is inside one of those .h files that we include, like IOStream and something that includes. I think secretly somewhere in there, there's a hash define that we don't know that says hash define size t space unsigned long. Okay, so I think there's a somewhere in there there's an unsigned long replacement going on. I don't know. I don't think it's a native type. Yeah. So it's just an alias that people created.
Oh, okay. Thank you.
I think so, right? So you should probably find out, and you should post this in Reddit, right? So we had this doubt in class, and I just Googled and found out, and I thought it'd be interesting to share this information because I don't know, right? Because I'm just guessing that it's probably an alias that someone created because I don't know. Maybe it's a native type since C++11, right? I'm like a C++, ancient guy, so. Yeah, I'd be interested to find out. And again, these are all interesting things to post about in the forums. And I'm not seeing a lot of activity in the forums, and a lot of people are, hey, by the way, Zaid, are you still in bed? Zaid, are you there? Are you awake?
Yeah, I'm here.
All right, you gotta keep talking or doing something, okay? Otherwise,
Okay.
I have no idea if you guys are okay. Fernando, are you there? Jared, Soe?
I'm here.
Who is this? Madison?
Yeah.
Yeah. Jared, are you there?
Yeah, I'm here.
Soe? You guys have to be interactive, okay? I think Soe, this is the second
Yeah, I'm
time you're
here.
not talking up, right? Speaking up, because even last quarter, on Tuesday, I called out your name. You didn't say anything. Okay, something is happening to your, icon. So I guess you're doing something there. Okay. So, but you still have to be vocal. So anyway, what was I saying? Yeah,
Anand, it looks like you're right. It does say since C++11 in the documentation.
Oh, exactly. It says C++11. It became a native type.
It doesn't say native, but I believe what is inferred is that it is native.
Wow. Okay.
Right.
Well, we can actually say, hey, Google, is size t a native type in C++?
Sorry, I don't have any information about that, but I found something else. Do you want to know, is iced tea an American thing?
No, thank you.
It's definitely an American thing.
It's definitely an American thing. Yeah, iced tea. Yeah, that does rhyme, doesn't it? Size tea and iced tea. Yeah. So one time I was at this speech recognition conference, right? So a long time ago, I think it was in 2005, 2006, maybe, right? And the conference was in St. Thomas, U.S. Virgin Islands. So, and it was on a fantastic beach. It was on a fantastic beach and all. So the slogan of the conference was how to recognize speech, right? so you can actually, on the beach side, it said how to rec a nice beach. On the conference side, it said how to recognize speech.
That's really good.
Yeah, and because that's
like
kind of
too
cool, right?
nerdy.
Because most speech recognition systems can't tell, right? If I tell Google, hey Google, how do you recognize speech? Hey, Google, how do you recognize speech?
On the website cmusphinx.github.io.
Oh,
they
actually,
say,
hey, Google, stop.
Ah.
Okay.
Speech is the following. We take a
Hey,
waveform,
Google.
split it
How do you recognize speech? Actually, I see peach. And
on the website cmusphinx.github.io. They say,
hey, Google, stop.
the common way to recognize speech is the following. We take a waveform, split it
Hey,
up
Google, stop.
by silences.
All
It
right.
gives you a GitHub readout. Jesus Christ.
So anyway, it didn't say it couldn't recognize how to wreck a nice beach, right? It couldn't, because it's not a very common phrase in English. So it's not part of the language model with high probability. That's how
Oh,
we
it's
recognize
it's not part of the training data set or something like
No,
this?
no, no. It doesn't have to be part of the training data anymore, right? Because it's all stochastic.
I guess.
It's probabilistic. But what we do is that in recognition of any kind, not just speech, right? You have a series of frames, and you have a graph. You have a graph of all possibilities. The person could have said that. The person could have said this. The person could have said that. The person could have said this, right? So there's many ways, many things the person could have said, right? Each one you can calculate a probability. Essentially, if you know statistics, you can calculate the probability of going from here to here and so on, and add up things and so on and so forth. So technically, you can use an algorithm to find out what is the probability that any of those damn things was said, and you just pick the most probable thing. And that's what all these systems say. That is, and if the probability is really high, you can say this is what they said with high confidence. All right, there you go. That's your crash course in speech recognition, right? Everything else is basically C++, right? Because it's mathematics, statistics, and C++, right? You just want to model a graph. You want to do a search algorithm on the graph, and you want to be able to be clever and intelligent in pruning, right? So you don't go down false paths, because that is the greatest danger in search algorithms, right? In search algorithms, if you have unbounded space, right? Unbounded space search algorithms, you got to be like super duper careful, never to get into a false path. Because once you get into a false path, you're totally screwed, because you get, the amount of time to get back is infinite. So you can come up with clever heuristics, clever ways of doing things, so that you can take tailor-made algorithms, stuff that you learn into CS2C, right? So standard search algorithms, and make minor tweaks to it here and there. Right, so you can take Dijkstra's algorithm and make minor tweaks. Maybe the tweaks are so much that it doesn't even look like Dijkstra's algorithm anymore, and that's how many algorithms are born, right? So then maybe it'll say, Ishiro's algorithm, something like that, right? Which may be a version of Dijkstra's algorithm, just like we do have many algorithms that are versions of other algorithms, right? And so there are tweaks you apply, and then it'll be suited for a particular domain, because you bring to bear a lot of domain-specific knowledge, which the general algorithm cannot use. And using this knowledge, you can say, well, you know what? This search, which used to be, n cube log n, I've managed to bring it down to n log n, right? And therefore, it's actually possible to do on a phone. Right?
I'm not very good at big O notation yet. I'm not super good at, conceptually, I haven't digested the big O notation stuff yet.
Hey, don't worry. You're only in 2A, right? So, but by the time, if you stick with this, in 2B, you'll already have a really good feel. And in 2C, you'll actually look at it formally. And then when you look at it formally, you'll actually know, because in 2B, you already have a feel for it. We don't even introduce it until 2C, right?
Okay.
What I mean by quadratic and cubic and so on is cubic is really, really slow, right? Like last class, we talked about quadratic and linear, right? So quadratic is, proportional to the square of the number of elements, like you're going to do with a vector, right? So finding all pairs of elements is proportional to the number of squares and the number of pairs, and the number of pairs is bounded by the number of it is the square of the number of items, n squared minus n over 2. Yeah. So it's bounded by the number of squares. So in the square, if you think about a mathematical curve, a square is a parabola. So initially, it may look like the parabola is growing slower than a straight line. A straight line is like that. A parabola may be going slower than a straight line, but very quickly, after 4 or 5 items, it's going to cross, okay? And it's going to grow much, much faster than the straight line, right? So 50 or 60 items, you're looking at, horrendous performance with a quadratic algorithm. But a linear algorithm will just be chugging along like the tortoise, right? And it'll be going cool. So, and that's the really cool thing about these algorithms that you'll get to learn, right? So, and it's really fun. When you get there, it's really fun, because then you get to look at many different ways of doing things and say, well, for this situation, that is the best, right? Whereas that may not be the best in other situations, right? And that is the greatest danger of being a self-taught programmer, I've found, when you employ someone who's actually not gone through formal CS, right? They may know how to do things, but they'll take the same way of doing things and apply it to everything. all right, which is not what you expect from a seasoned computer science person, right? Because, just because there is a way to do it, that's not the way to do it everywhere. So, and I think I made this point last class too, right? So good software engineers know many different ways of doing everything, right? It doesn't mean that they do it every single time, every day, right? They just know. And the way to get there is not by learning many different ways of doing things, but just by examining a carefully selected few, right, random samples, and saying, I've looked at many different ways of doing these things, not all obviously, but many, and they all seem to be doing exactly the same thing. What is it they all seem to be doing, right? And so abstracting it out, and once you get to know what is it they're all trying to be doing, then at that point, you stop knowing how to do 15 things anymore, right? You immediately say, I know how to do an infinite number of things, right? Because you've abstracted out what they want to do, then you can do it in any damn way. Right? So, and people always think, I think, when they learn a programming language or anything, right? So there's so many different things, and these experts can do all of these different things, and it's going to take me a lifetime to do it, right? I'm never ever going to be able to learn all of these different things, right? And but if it's not like that, right? So even if you go and that's what they teach you, right? So you don't have to learn all of these things. You learn a few carefully selected samples, automatically at one point, you'll just know how to do all of those things without having to explicitly know. So that is what distinguishes an expert, I think. So that's what I find fun about talking to someone. If you hire someone who actually has a solid backing in computer science, it's actually fun to talk to them, because when you have a problem, they'll actually propose many different ways of solving it, right? Rather than say, all right, I can solve it for you, right? That's not the right way to do things, right? So I say, hey, that's an interesting problem. We can try, this way, or maybe we can try that, right? And so that's the way to have an interesting conversation. That's what people are paying you for, basically, I think, right? Because just getting things done, you can get it most of the, in a particular way. If you spell it out in excruciating detail, there's always people that can do it for you, and so. Yeah, I think that's the way to do it. If you guys want, pick up the screen, right? Someone pick up the screen. Someone other than, hey, Soe, you're back. All right. So do you have a computer, Soe? I can hear you.
Yeah, I have a computer.
You want to share your screen? You
Yeah.
can drive today, right? I think Zaid last class, and they handed over to Alexandria. If later on, if you're tired, you can hand over to someone, right? Jared, or someone can take over from you. You want to take the screen? Yeah.
Okay, I'll take the screen. I haven't done that before.
Great, thank you. That's fantastic. All right, so the code from last week, just get it up in a separate window, right? Let's and create a brand new. I think someone posted something in chat, right? I didn't see it, right? And by the way, I can't see chat, right? I don't have that window. I don't have the luxury of devoting, screen real estate to the chat window. Oh, there it is. Oh, that's yeah. Oh, it actually flashes by. All right, so yeah, Alexandria, I just posted the link. Open it in a different tab. So what we'll do is, and then in this tab in online GDB, let's just create an empty C++ program, right? With a main, remove all the comments, just hash include IOStream, and let's just use namespace, right? So that we can type less, and then an empty main. We'll start filling it in. We'll copy over stuff. And then you guys can say, can we do this? Can we do this? Can we try this? Can we so on and so forth? And we can do that, right? And every time I'll set up a small problem, and then I can basically either step away or I'll stick around. I'll stop video and mute myself, and I'll stick around, right? So I'll be here. Many times. We'll do that many times, right? So I think I want to bring it down to like 5 or 10 minutes, because we put a comment there, someone starts coding, and then I disappear like 5 or 10 minutes, right? Still within earshot, and you guys take over and code, right? And then I hope we can come up with a system where this this procedure is repeatable, rapidly repeatable, right? So that if this works, then we'll say, this is the model, okay? Future students too, this is the model, okay? Watch this 5-minute clip, all right? We're gonna put a comment there, and this is what we're gonna do. Someone take over and do this, you all do it, I'm gonna disappear, I'll come back after 5 minutes or 10 minutes. Does that work? I think that's really cool, right? We can try that? Yeah, all right, good. All right, so take the screen and then open online GDB or something, and share your, by the way, Chrome, right? When you start Chrome, Command Shift and Mac or Windows? Yeah, close.
I'm on Mac.
Close, yeah, kill Chrome and get into a private window, right? Command Shift N. Command Shift N.
Measure that. Okay.
No, kill Chrome. Yeah, and open a or close that window. Hit the red circle. Hit the red circle. Hit the red circle.
Yep. Yep.
Yeah, kill
Yep.
it. Yeah, kill it, and then hit Command Shift N. Did you get a
Okay, and
private
then
window?
open on the incognito window then?
Yeah, just do it in a private window, okay?
Yeah,
So
the incognito one.
yeah, otherwise you'll accidentally reveal passwords and shit like that. I
Okay,
can't see your screen, by the way.
I know, yeah. There we go.
Did you share? Yeah, okay. All right, and then in another tab, you can click on Alexandria's link. So what we're trying to do last class is you had a function, you pass a vector, it does stuff with the vector and return a number. And then you tried, you can ask me, all right? That's, oh, I see, and you, and we had, oh, we tried to time it and all. We tried to time it so we can create a Google spreadsheet.
Yeah, we didn't finish with the timing.
You want to do it today? We can do it today. If you
Yeah,
want
can
to-
we do it?
Yeah, in fact, you guys will do it. I'll just tell you guys, hey, so just clean up the, get rid of the top comments and everything. And in fact, at the very top of this file, get rid of the comments and put in our comments saying this is the source file for what today's class, put today's date, today's C++ class. We're playing around with C++ code, and right later on, maybe, and you can see the video on YouTube or whatever it is, right? So that
What was the timing thing that you guys were talking about?
Alexander, you want to talk about it? I can.
Oh, sure. So we had two methods that calculated the average of like a vector, like values of a
Right.
vector. And one of them took in like a reference professor, and the other one took in a value
Yeah.
for the
Uh-huh.
vector. And so we were gonna time, like, give this huge vector to both methods and time how long they are. So like see which is faster.
We'll do that. You
Okay.
know what? When you describe it, it sounds like a great fun experiment to try. We can do that today. And in fact, you guys will do it because I'll just say, one step at a time, I'll say someone do it. Okay. And I think it'll be fun. All right, all right. So let me look at your screen. Hey, what happened?
Okay,
What'd you do?
so that's the code from previous class. I
What
just
is
created a
that?
separate tab.
Oh, it was, I see, his JavaScript didn't format it properly before. I mean, I hadn't started formatting. I see. Okay, all right, cool. So, and so this is with ampersand and that one is without ampersand. So you wrote two functions. Yeah, I remember this. Okay, you scroll down just a little bit. So, and in your main, okay. All right, a little bit more. All right, so you want to call the get average function. Oh, experiment with and without the and. Okay, all right. So, all right, great. Thanks. Okay. And what are you doing? Time to start with and. All right, yeah, that is in fact, yeah. So, fantastic. I'm glad you guys came up with this is the standard way in which people measure things. Time equals now, or now equals time. Or then equals time or something, exactly what you guys are doing now, right? And then, that current time minus what the stored time, that is total time. The only catch here is that, and, I wanted you guys to run into this problem, right? Now, after I explain this, you will be able to solve it. So I want to step away, right? Unless you guys call me. And you can tell me if you guys all understand it and you're able to solve it. So I'm going to try and leverage the same method that my daughter was taught in elementary school, okay? How to find the size of one dime, right? The thickness of one dime, right? And it's very hard to find using, a ruler, right? If you have, even an inch tape or something like that, the markings, right? So what she was taught was you can't do it correctly that way, or you can do it, it's not going to be accurate. So stack up 10 of those, measure the height of 10 the stack of 10 dimes and divide by 10. Okay, so here we are stuck with exactly the same problem. The granularity that time reports is the markings on that inch tape, right? They're too far apart, 1 second apart, whereas our functions take fractions of seconds to run. So our granularity is totally out of whack. We can't measure it. The only way we can measure it is if we say, this function, I don't want the time it takes to run one time, because that's going to be like 0.2 seconds, but give me the time it takes to run 1,000 times, right? So you're going to call a function, right? Which is going to run the actual function 1,000 times and then return the result. Now you can measure how long that function took to run and divide that by 1,000. That's the time your function took to run. Does that make sense? Okay, all right. So that's how we can find the time. Now, however, before I leave this in your hands, right? I have to put the first comment in there, right, for you guys to start, right? So let's try and be absolutely really scientific about it, meaning that we want to make sure that we want to try to make it a controlled experiment. What is it? What do I mean by a controlled experiment? A controlled experiment is where as many irrelevant factors as possible are gotten rid of. Yes or no? First of all, does everybody understand and agree with me that a controlled experiment is one in which you have enough control to get rid of everything that is a distraction, not useful in making a decision, right? Irrelevant to your, is that a control? Right? That's what you do in science experiments, right? So like pendulum and swinging, that if you're only looking for the length, right, versus the period, you want to make sure that everything else is as identical as possible, right? You don't want to use a heavy bob one place and for the long string and a small bob and the small, right? So you want to make sure everything else is the same, only the length is different. That's how you can tell that. So that is controlling for the length. So it's the same mindset here. So when we run an experiment, let's run it like a scientist and say, what are we trying to do here? We're trying to see what is the effect of passing by reference versus passing by copy, right? That's what Alexander said, right? So that is it. So let's try and say, let's say that if that is what we want to know, let's try and control the experiment so that everything other than passing by reference and copy is kept to a bare minimum, which means that our algorithms really functions shouldn't be doing anything at all, right? If you make them do crazy things, random numbers and so on, right? Then it dilutes the whole thing, right? It adds noise. So what we'll try and do is go to the two functions that we have, and I'm going to put a comment, and you guys are going to clean it up, okay? Go to the two functions that you wrote before, right? In your code at the top, the two functions, right? So get, average, let's call them different functions now, just to make it all very clear, right? A function, let's call it a function with vector passed by reference. Instead of get average with amp, just double click get average with amp.
You might have to do fork this.
Oh, it's your code, is it? You have to fork it. Yeah. No. Copy that function. Copy line 7 to 13. Command C there and take it to your window and paste it there. Copy line 7 to, because that's the one we're trying to edit, right? So copy line, yeah. Again, I want to remind you, you weren't here, right? It's a whole lot easier to triple click and drag, right? The triple click is a whole lot easier than clicking and dragging. Okay, all right. So just put that above main. No. You can't have a function inside main, not yet, right? So put it on top of main, above main, not inside. Command Control Z or Command Z. Yeah. All right. Put it there. All right. Put some blank lines before and after. And also rename the function now. And let's call it, a blank line after, and let's double click on get average with amp. Double click. Now let's call it function with vector passed by reference. Function underscore. Oh, you got to have underscores instead of spaces, right? With vec passed by reference. Vec underscore. Yeah. All right. Vector passed by reference. Because the name is self-documenting, we're basically saving ourselves the trouble of putting a comment up there. Yeah, passed by reference, passed, 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 ed underscore by underscore ref. Just say ref, right? All right, now we want to be the scientific mindset said, let's not mess around with the vector. All we're going to do is basically just return 0, right? You don't have to calculate anything, because calculating things was going to throw things off kilter, right? Not off kilter, but it's going to introduce noise. So get rid of the whole thing and just return 0, right? All we want is a function that takes the vector by reference. Yeah, just return 0. You can do a cout here. You can do a cout saying cout. No, get rid of the whole inside the function. Get rid of everything inside the function. Get rid of everything inside the function, and just say, let's not even have a cout. Just say return 0, right? Return. Just say return and make it a void function. Return and make it a void function, right? Return. Just say return semicolon. You guys haven't written a void function before, so all right. And get rid of long. Get rid of long. Get rid of long and turn that void. And turn the long into a void. Yeah, void. That means this is a function. Okay. What void? Turn void and space, and then get rid of the blank line before return. All right. I hope really that the compiler does not optimize this function out. All right. So yeah, one more backspace. Push it in. Indent. Tab. All right. Good. Good. Now, yeah. So the risk with doing this on an online site like Online GDB is that they may employ some optimization flags, and the compiler, any compiler today, right? Even simple compilers, they're intelligent enough to know that this function doesn't do anything. We'll just optimize it out of the code. Meaning that when the compiler translates your program into machine code, this function is not even there. It knows that this function doesn't do anything. So every time there's a call to this function, it basically deletes it, right? And the function code is absent in your code, in your final compiled version. That's because the compiler is intelligent and optimized out, right? So I hope it doesn't happen. It is possible to tell G++ to not optimize it, all right, with a flag. It says a dash O0. You have to specify that on what is called a command line. We'll find out if it's necessary. We'll find out if it's necessary. We will, and in fact, it'll be good to. It's a good experiment because we'll know whether it's necessary or not. Okay, now the comment for you guys to implement is that now you know what to do, right? So basically put a comment saying, because I want to take off, right? Not take off. I'm gonna give it to you. But put a comment above main, right? Or somewhere above main. Put a comment saying this is what you guys have to do, right? On line 16, hit enter. Yeah, blank line before that line. Blank line before that, because this is your to do item for you guys. Okay, to do, yeah, comment, yeah, no, to do for you guys. Yeah, to do colon, right? So now this is what would be good to do. You say have another function which takes a vector that is passed by copy, right? Create another function like that which takes a vector passed by copy, or create. Just say not have. Yes. Create another function that takes a vector passed by copy, and then in your main method, the one thing you can do is experiment with vectors of sizes 10 all the way up to I don't know 100 million. Okay, let's say 100 million. 100 million will easily fit in a long, right? Size T goes all the way up to 4 billion, right? Because size T is long, unsigned long, and unsigned long is 4 bytes. That's 2 to the 32. 2 to the 32 is 2 to the 16 times 2 to the 16. Yes? Now 2 to the 16 is 65K, right? Now 65K squared is basically 65 squared times K squared. K squared is a million, right? 65 squared is, around 4 billion. Right? No, for 4,000. I don't know, somewhere like that. Yeah, around 4,000, right? 3,600, 4,000, right? So 4,000 times a million is 4 billion, right? That's how we. So a long is a very average ass number, but that's how we get it. 4 billion. A size T can go all the way up to 4 billion. That's how we say it's 4 billion. If it's 4 bytes, it's 4 billion, right? There's 2 bytes is only 64K. All right, so you want to create another function which takes a I've done that. Which takes a vector passed by reference, which takes a vector passed by copy. That's number one, right? To do for you guys. number one. That's your number one item. In fact, you can take that to the next line. I'll give you 3 or 4 things to do, right? So because it's going to be really simple, right? So take that to the put the number one in front of create, and then take that to the next line. I'll give you a few more things like that, right now. Yeah, take that to the next line and say that's 1 point. No, take that to the next line, right? And make that also a comment. Yeah, sweet. All right. So and then put a space between the 1 and the create. It's the 1 and the create. Yeah, on previous lines, create 1 space before the create. No, 1 space before the C. 1 space, because the word runs into the number right now. All right, good. All right, now number 2 will be in your main. Number two will be in your main. You want to you want to experiment with filling the vector with randoms and having an empty vector, right? In both cases it should work. If it doesn't work, it's because of some optimization glitch, right? So you can write it down, right? In your main, you want to experiment with filling your vector with random ints. And your randoms, by the way, don't have to be %50 or %1000 or anything, because you have such a large number of randoms. Just assign whatever rand returns, right? Your random is going to be somewhere between 0 and 32K, right? It's going to be some number there. So just assign. You don't have to do % and all those things, right? Just in case. It's in your main, you want to experiment with randoms, random ints in your vector, and empty vectors, right? And empty vectors, random ints in your vector. Integers plural, right? So because in your main, I noticed that you have a for loop and you're stuffing empty integers into your vector, right? So you can try that, and but that is not going to make a difference because it's outside of your timing loop, right? So you can do anything to your vector, right? You can do some crazy things to your vector, but your timing loop should be really tight, right? You shouldn't be doing averages and stuffing a vector inside your timing loop, because in your timing loop, the only thing you want to distinguish is ampersand and no ampersand. Everything else should be exactly the same, right? Even if we have things that are adding in both places, that's a source of noise, right? Because who knows, alpha particles and things like that, it's irrelevant. So you want to get rid of it. That's why you don't want to do the average and everything inside the functions. So that's what you're timing. So that should be tight. However, you can do averages, you can stuff the vector with randoms, you can do everything you want. You can do outside of the timing part. You can do it here, you can do it here. That doesn't matter. Is everybody okay with that? That's how you measure things, right? Yes? Okay, all right, good. So in your main, you want to experiment with random ints in your vector and empty vectors, right? You can break your line after in your, right? You go on to the next line, so that's easier to read for other students too. So on the previous line, on line 20, you go on to the next line after in your, just before vector, hit enter, go on to the next line. Yeah, all right, comment, right? In your vector and empty vectors, if it makes a difference, it's probably because your compiler is doing some optimization there. Discuss why, right? You can write that there, right? It's probably because, no, you can just say discuss why that might be the case. Discuss why it may be the case, right? Discuss. No, not this because, right? Discuss, DISCUS, right? You guys can fill in the punctuations and things later, okay? So we're not going to fix the grammar and things like that, all right? Discuss why this may be the case. All right, number 3, in your main, you want to time both functions by calling them in wrapper functions thousands of times and averaging, all right? Time each function by wrapping them in I don't know, in caller functions. Yeah, I'm just calling them caller functions. You go to the next line. Go on to the next line. No. Go on to the next line. It's not color. It's not. It's caller. Go on to the next line. Yeah, next line. Right. Comment. Open comment. No. We're still continuing with the number 3. We're still continuing with number 3. Yeah. 2 comments. Yeah. All right. Space. And then you'd say, wrapping them in caller, CALLER, caller functions. Or you say other functions. No, not caller. Just say other functions. Calling them not caller, right? Just say other functions. Other functions. And which call them thousands of times. Which, by wrapping them in other function, which call them thousands of times and return the average. which call them thousands of times and return the average. And returns the average. Yeah, does it make sense to everybody?
Quick question.
Yeah, sure. Go ahead.
So when you say discuss why this may be the case, you're referring to what exactly again?
Well, yeah, this is my hypothesis. Okay, so they should be identical because that's outside of the it's outside of the timing loop. Oh yeah. The function in your domain, you want to experiment with random ins. Oh yeah. Sorry. So in one case, your vector is empty, size 0. In another case, your vector has actually got numbers in it, right? It should not make any difference as long as the vectors are the same size, right? So 100,000 element or a vector, which is all empty zeros, right? Another 100,000 with integers, and you pass by copy. Actually, the times will be different. The times will be different. That's really cool. Okay, so that's really nice. We'll find out. And so the reason it'll be different is because in the one case, it knows the size is 0. So passing by copy should take the same amount of time as passing by reference because it doesn't have to copy any elements over. It just needs to say, here's a vector and the size is 0. It doesn't have to copy the individual elements over. Yes? But in the other case, it has to copy all of the elements, because the vector is not 0 size. So it'll take longer. So you can find out, right? It's like detecting gravitational waves, right? Setting up these tests to find out that, if the vector is empty, you can actually tell just in the timing part of it, right? So we can find, but it'll be interesting discussion, right? I can come back for the discussion part if you want. I was thinking before that it might be, if the times should be identical, if they are different, it might be because of some funky compiler optimization because of empty vectors and full vectors, but there is actually a very valid reason why the times should be different, right? And it's an interesting reason too. So when we come to it, it'll be a very interesting bridge to cross, okay? So number 3 is that. Does it answer your question, Neil? I don't have the answer yet, but I think you'll find out.
I think so, but you
I'll be
said
here.
one of the vectors you said is outside of the like caller function. So what are we testing by calling those two functions thousands of times exactly? That's the part I'm confused about.
Oh, Neil, you weren't here last class.
Oh yeah, sorry.
Yeah, okay, that's why. Right, what
My
these
bad.
people are trying to find out is if you pass by reference, does it give you a significant win over passing by copy? Or what are the
Okay.
situations in which you would use one over the other? And are there any time differences to passing large objects by reference versus copy?
Okay.
Right, that is what people were trying to find out last class. Right, because this week is entirely supposed to be devoted to functions and function calling and parameter types.
Okay, cool. Thanks.
Yeah.
Sorry about that.
Okay, no worries. Okay, but are you on the same page now? Are you able to? All right. So you should also be able to contribute to this code and and code it. Okay. So all right. So is everybody okay with number 3? This is how you find the average, the time taken by right. Number 4. Yeah, right. Number 4. In a separate document, open a Google spreadsheet or an Excel spreadsheet. Separate tab or a separate document, right? Open a Google or Excel spreadsheet. Right? Spreadsheet have 3 columns. The first column should have the size of the vector. No, go to the next line. Every time you get to that column, just hit enter, right? Go on to the next line. So yeah, that's easier, right? Yeah. All right. Yeah, the first column should be the size of the vector. In the first column, the size of the vector. The second column should be the time taken by function A for that size vector. And the third column should be the time taken by function B for that size vector. Right? Vector. And you can have 2 sets of those numbers, one with empty vectors, one with full vectors full of random numbers. Okay, so Excel spreadsheet with 3 columns, actually 6 columns, right? 3 and 3, 2 sets of 3 columns each, right? Basically, that's what you want. 2 sets of 3 columns each. In one, you're going to have the timings, Everybody okay with that? Right? All the way from 10 up to 100 million in steps of, I don't know, you can choose a logarithmic scale, right? Choose a logarithmic scale, 10, 100, 1,000, 10,000, 100,000, million, 10 million, 100 million. Okay, so how many rows does it give you? 100 million is 10 to the 8, right? So it will give you 8 rows, right? I think it should give you 8 rows. And 8 rows should be enough to plot on a graph paper, or just, highlight the 8 rows in Google Docs or Excel, and you should be able to right click and say plot a graph right there, bam, like that, right? And then it'll show you, a function that where you pass by reference, the time taken as the vector grows, the vector is getting bigger and bigger, but the time grows like this, right? You pass by copy, and the vector getting bigger and bigger, and time also gets bigger and bigger, or something like that, right? So you'll see the shape of those 2 curves when you plot it in Google Docs. You can repeat it for more data points too. If you want more points, you can say 1 to 100 million. Instead of 8, I'm going to get 16. So you also stop at the 50,000 mark, and halfway mark there. So you get more data points and get the smooth curve. So those are your 4 items for today, and you got a whole hour, I think, pretty much. Are you guys happy with so far, what we've got so far for you guys to do, right? I'm just going to be here, okay? I'm just going to be here. Maybe I'll just go make a coffee or something, and I'm going to, I'm just going to be here. Just call out, right? And be loud, siren or something if you have it on your Mac, right? And I can be back here. I'll come back and maybe sit down at some point and watch the code too, right? But feel free to. Is there enough to-do items for you for the rest of today? And this is also, in a sense, refactoring code that you wrote last class, in some way, right? I'm not refactoring, you're refactoring the code by basically taking chunks of your code and putting it here, whittling it down and changing things around, wrapping one of those functions in another function so you can call it in a wrapper and so on. So that's all part of refactoring, right? You're going to be doing so much of this, you might as well start doing it now, right? So I'm not refactoring your code, so you're basically refactoring your own code. That's, if you think about it that way, it'll be a whole lot easier. Can you guys take over from here? Yeah, can I just mute myself and basically hand over to you guys? Is that okay? And hey, who's Soe, right? At some point, you can basically let someone else fork this code, right? I think there's a fork button somewhere. Must be a fork button somewhere, right? So you can let someone else fork this code and hand over to them if you want, right? If someone wants to. Ideally someone like Neil, maybe, who hasn't had a chance to take the screen so far. Neil, have you taken the screen before? Are you in front of a computer? Are you at work?
I mean, I'm here. I'm in.
Are you at
I'm
work now?
taking. Sorry.
Last time you said you were at work and you couldn't take the computer or something.
Yeah, I'm good now though. I've taken the screen a couple times earlier in the quarter, but not.
Okay, all right. At some point today, maybe you guys can work out, coordinate. I haven't seen the whole class, right? Because I wanted to keep the font size. You guys, you guys coordinate amongst yourself. Zaid probably has to go sooner. So if he wants to go, he should probably go sooner than other people. But he just had a chance last class, so that doesn't matter. Jared, maybe, Yang Yushin. Do you have a computer now? You should go to the STEM center, okay? You can't be programming with your phone throughout the quarter, okay? It's going to be really, really hard, right? Okay.
Yeah, I know.
You have a computer? You have a computer now?
Yeah.
Oh, you can code too. Yes. All right. You don't have to make up your mind now, but you got to code either later today or Tuesday or Thursday or one of these days, all right? Coming up.
Okay.
All right, good. It'll be easy, okay? By the way, next week is week 6. Week 6 next week?
Yeah.
Midterm week. Typically, I didn't used to have a lecture on midterm week and on final week that introduced new material. And I'm happy to do that again, right? We don't want to introduce objects next week, week 6. We can wait until week 7 to introduce objects. So if you guys want, we can still have a class Tuesday and Thursday as usual, but we'll just do review, right? Any concept from data representation or representation all the way up to the, what we're doing now, functions. If you guys want to, test drive like now, you should just be able to do it Tuesday and Thursday. I should just be able to watch, right? And guide you just like today. We don't have to do objects until the week after. Are you guys okay with that? Do you want to have a kind of a review, a couple of review sessions next week? Yeah. Great, great. In fact, you know what? I think I should offer it also to my CS2B students. Those guys are, I don't know, very few people are actually managing to flow through, and many of them are stuck. No amount of investigation seems to suffice. But I need to, yeah, maybe I'll offer a class, maybe even a joint class, maybe some of them could actually use. No, I can't do a joint class until you get to, quest 9, because they're dealing with pointers all the time. That's why, by the time you're done with 2A, you should be comfortable with pointers, okay? Because 2B, impossible to scale it without knowing what pointers are. So just make sure that whether you, stick around in 2A and pass the course or not, doesn't matter over the Christmas break, by the end of the Christmas break, before you start 2B, make sure you get all the way past quest 9, finish quest 9, because that will make sure you're solidly grounded in pointers, and then you'll be happy. It's a set up to succeed in 2B. Right. I'm going to take off now. Hey, who had the singing? So you good? You can hand over at some point to someone else. Yeah, and you guys should feel free to speak up. Okay, saying, can I take over? All right, I'm gonna take off. All right, see you guys later. Okay, just call me if you need me. All right, bye. Happy coding.
Bye.
What's up, Sawyer?
Hello.
Okay, so sorry, I was gonna
Okay.
ask, but when it said pass by copy, we haven't written that yet. So what is that about? Like I know there's like the copy constructor.
Yeah, I think it's just. Oh, actually, I lied. It might be the copying constructor, or it might just be not using the reference. Because when you pass in object to a function and you don't pass it by reference, it creates a copy of the object. I think so. It might be saying like pass the exact object or just pass a copy of it by not passing it by reference.
Do you mind adding that into the comments just so it's clear what is going on?
Yeah.
Yeah.
Thanks.
All right. What is it?
Okay, so when you don't specify passing by reference,
Passing references.
yeah, passing references, then functions, and anyone please feel free to correct me on this because I'm not 100%. Functions create a copy of the object you're passing.
Okay.
Object you're passing, sorry. Not or.
Wait, what was it?
Your, yeah.
Your, okay.
Yeah. That's what I think like this is what I remember is just when you don't specify that you're passing by reference, then the function will automatically create a copy of the object in that while you're running it to use. So that's why you have to specify passing by reference. Like that's the whole reason that exists. I'm pretty sure. Alex, you have a confused look on your face. Do you want to correct me on something, please?
Oh, no, it's just weird. It's not like Java. That's all.
Oh, okay.
What does Java do again?
Like Java is always passed by reference, but I don't want to confuse everyone.
And then what happens after the function's done? The copy just goes away.
Yeah, the copy will just go away. It's out of scope.
Cool.
Yeah, so okay, I guess it's called pass by value. Basically, when you just pass a direct value into the function, then it'll create a copy of the object. Here, I have a thing. I think this might clarify a bit, hopefully. Check
So
chat.
with vector, it's weird. Does it really make a copy of like everything in the vector? Like I don't know. With string, it makes sense. I don't know. Maybe I'll Google.
Even if but we're making a really huge vector, right?
Yes.
And it's not gonna like crash. I don't know.
It does crash. We tried it last
Oh,
week.
okay.
You make it too big,
Oh.
it crashes.
Yeah, no, that's what I was like, wait, what? Yeah, okay. That makes
Yeah.
sense.
So it looks like it'll turn out all right, but it just will take longer with when you pass by value or copy with a vector, because it's like the longer the size, obviously, which is why I think he said do it with like a size 10 and a size 100. Oh, really, Agnes? I did not notice that. It's been accurate for me so far. I don't know.
At least for networking things, sometimes they lie. But anyway.
Oh, okay. So, I mean, we need two other functions, right? We can start there by laying out the framework, I guess, right?
Yeah. We should just copy that function and then get rid of the ampersand.
Yeah.
So you can just copy paste.
Okay, so
So lines 12 to 14, you can just copy that and
Yeah.
then on a new line, just paste it.
like before,
Like
after
before
the
before main.
constant,
Before main.
before main.
Yeah, so if you just yeah. And then what you want to do is you want to delete go down, go back to that do the function. Or no, keep that one. So
We're
you want
just
to
using
keep,
as like a
Oh, okay.
template, right?
yeah, you're just using it as like a template. Okay. So what you want to do is remove remove the ampersand. And then remove the, well, I guess you can keep the constant. Because does everyone know what constant does? Const.
Remind me.
Sure. So it will either throw a compile error or a runtime error. And const means if you try to say vec equals something new, it'll throw an error.
Yeah, so basically
Okay.
it just protects it from being edited within the scope of the function.
Oh, yeah, it's okay.
Yeah.
That makes sense.
Okay. Yeah, so and then you want to change the name of the function to from ref to copy. Yeah, since we're different function. Also, do we have to name it that exact name? It's a good name. We can shorten it, right?
It's a clear name,
Okay. Couldn't we just say like pass by copy?
whatever you want.
Do we have to say function with the pass by?
Nah, we can do pass by
It's
call.
fine, it's fine. Whatever. I mean, it'll probably show up in tab. I don't know if I forgot if online GDB has that, but okay. And then we want to fill in, or we want to create one more function before main, which is the like wrapper thing. So we call that like, I don't know. What should we call that? Someone?
Function timer, maybe?
Sure.
This one actually is going to time the functions, right? I mean, and return the average.
Yeah.
Or maybe function average timer. I don't know.
Yeah. Okay. So in the in this function, like for both of these functions, pass by copy and pass by reference, do you guys know what we're doing inside of them? Just iterating through, or
Oh, so I think he wanted us to do nothing to start with.
okay. So basically just passing in the function and seeing how long that takes. Okay. All right. So I guess that, I mean, this is, since they're just returning nothing, it's just calling the function, which is, that's what we're timing, is just how long it takes for the function to pass in the actual vector. Right, so then for this function 38, we'd want to print stuff out, so we wouldn't necessarily need to return anything, right? We could also just use a print statement since we're averaging, right? Thinking about the return type, we could just make it void for 38.
Yes.
Yeah.
Yeah, we can just print some.
Okay, so the return type could be void. So soy before that, yeah. And then we want the curly braces. Yeah, okay. Anyone want to jump in here?
So is this function, is this actually timing this function?
It times it and then returns the average, right? Can we shift over? Can we copy and paste the comments to align with the actual functions that's talking about? So we could just not scroll up and down. Like
So what do you
move
mean?
comment number 3 next to the actual function that we're writing.
Okay. Just move it to this one.
Yeah, like right above it or something, right above the function average time. Thanks.
Okay, so we'll start by measuring the time, right?
Thousands of times,
So
which you guys wrote last time, right?
yeah, so we just did like long start time equals and then time null. So that'll grab the start time. I'm not sure if it's in seconds. I think maybe. So on line 41, you can do like long start underscore time.
So like,
Yeah, long and then start. Oh, sorry, space. Long space, because long is the type.
Okay.
So start underscore time equals, and then I think just time parentheses, and then all caps null, and then end that line with the semicolon.
Yeah.
So we're gonna have to pass in a function as a parameter, right? Neil, you were kind
Yeah.
of leading.
I mean, well, technically we don't have to. We could just call it.
Okay, we can start with calling it. So what we have to do is in a for loop, you do like for size t.
Yeah.
Right.
So we have to consider that while we're iterating through like 1,000 times and calling this function, we also want to add the okay.
So I think what we would do is we call the function like thousands of times and then records the end time, and then we print out start, or we'd print out end minus start divided by like I or the number of times we ran it. Am I understanding what we're doing?
Yeah, but the only thing is time returns the amount of seconds that have passed since like what, 12 a.m.
So it should be fine. If you subtract the two, it'll find how much time passed.
It'll still do the difference. It'll cancel, you're saying? Okay.
Yeah, it'll get rid of since 12 a.m. So I tried this on in my own thing and it worked.
Okay, wait, so you're saying we add all of this like start times to, like, how would you keep?
Oh, so no, all we have to do is record. Okay, record the start time. Like, when did we start calling the methods? And then call the methods thousands of times. And then at the end,
Oh, okay, but he wanted us to take the average.
yeah, so then you can just do end
Oh.
minus start divided by how
I guess so.
many.
Yeah, that's kind of smart. Okay.
I've done it before, so I can't take credit.
No, that makes sense actually. Yeah. Okay, so we start the
So we
time.
also need an end time variable.
Yeah,
Yeah,
and then
we'll
we need to
need
do
an
that
end time.
twice. We need to do that once for reference and once for copy.
Mhm, mhm.
So
So
we
the
can
next thing.
do, oh, go on.
No, I was just gonna say the next thing to do would be to write that for loop, right?
Yeah,
Yeah. So sorry, on the next line, if you want to hit enter. Yeah.
But we're still not writing in main, right?
No, not yet. Once we finish this function, then we should be able to call it in main. Okay, so
Okay.
then you want to say for, and then parentheses, and then I equals, actually, wait. Just 1,000 or 1,000, right?
so
I
it'll
equals
be
1,000.
size underscore t.
Why size T?
So in for loops, you have to say the type of I. So size t is unsigned int.
But
So
since you're calling, since you're just calling a function, like that's all you're doing, right? Couldn't you just do
Oh.
int I equals 1,000 and then just keep iterating I and just keep calling?
So with the for loop, you usually start at 0. So you start I equals 0, and then
yeah, sorry.
I is less than 1,000.
My God, I've forgotten.
Yeah, I did this last week. I kept forgetting to put like a type. So could you do int I equals 0
Say
in the
int
for
I,
loop? Yeah, int I equals 0.
so like here and then,
Or no parentheses, just a space. So you're making I a variable, but it's only in the for loop. So you do semicolon after the 0. And then this is what Neil was saying. You do I is less than like 1,000. Yeah, and then semicolon, and then I plus plus. So this will make sure every time you run the loop, you add 1 to I. So the loop will run 1,000 times.
okay.
And then in the for loop, so you can do curly braces if you want. So
In the for
like,
loop,
so like start curly brace now. Like open curly brace. Yeah, and then enter. And then we can call our method. Does that sound good, guys?
Yep, it does.
Okay, so which one should we do first? We can just do, can you copy the function with vect passed by copy? Or just the name of the method? We're gonna call the method.
just the name of it then.
Yeah, we're just gonna call it in the loop. Cool. Yeah, and then we'll have to give it a vector. So Neil
Oh.
unmuted. So
Yeah, sorry. We want to make sure to define that in. Okay. Oh. Okay. I think we want to give average timer 2 parameters instead of the functions. We want to do or I guess one parameter, which would be the vector that we're using to test.
oh yeah, that's a good idea.
Yeah. So in the definition, sorry, in line 40 in the parentheses, you want to include a parameter that's would be vec int. We're using int. Vector int, vector int, and then just give it a name like, I don't know, v, and make sure to put the int in the angle brackets, the greater and less than signs.
In there, oh, okay.
Yeah, and then give it a name, like we could just name it V or something. What name, guys? Help me out here. I'm bad at naming. Oh shoot, say left. I missed that. Okay, yeah, and now we have a parameter that we can use. I think this is fine, right? We don't need to specify anything else for this.
Yeah, it should be good.
Okay, and then now we can call a function with vec pass by copy, and then you can put parentheses at the end of that at line 43 and just put in V. And it'll read the, yeah.
Sweet.
Alright. And do I need a semicolon at the end?
Yeah, yeah, nice.
Mm.
Okay, and then just copy this for loop that you've written.
Okay.
And then just hit enter on line 44 and then just paste it again.
Line 44. Okay.
Yeah.
And paste it again.
And then change copy to ref on 46. Okay. And then the other thing we need to do is do end time and then do the print for both of the for loops. Right,
Okay.
Alex, right?
Yeah. Oh,
Yeah.
so could you rename start time to start time underscore by underscore copy? Or we don't need that. Okay, just start time. Keep it that. Okay.
Okay.
So after the for loop, the first for loop, below so line 44 below the for loop. So outside of the curly brace. Yeah.
Yeah.
Could you do long or enter and then long end time?
Long end time.
Yeah, long end underscore time equals time null again. So what we're doing is
Okay.
we're recording start time is before we start calling the method, and then we call it 1,000 times, and then we grab the end time. So what we can do now is do C out, so semicolon. And then we can do C out. Oh, so you do C out and then you do less than. So you can get rid of the first two less than.
Okay.
Yeah. And then C out less than. And then you can do end time minus start time. So this is what Neil and I were talking about. So this will just get the seconds that the for loop was running. And then, yeah, that'll print out how long it took. And if we want to get the average, we can, could we skip getting the average to start with? Because when I did it, the average was like 1. So it was like so useless.
That makes sense. Sorry, I don't know if my audio is coming through
Yeah, we can hear
that
you.
well. Okay, cool.
Yeah.
But wait, so we're only doing 1,000, so I guess it's not that bad, but it is gonna print out 1,000 like end time minus start times, right? And then we're just
the C out is outside the for loop, so the indentation's a little weird. So it should only print once.
cool.
Okay. So then we'll do start. You can copy line 41, and we're just gonna re-grab start time. So you can copy line 41 and paste it in 47.
So line 41, paste in 47.
Yeah, so we're gonna grab a new start time basically and get rid of long there in 47. Otherwise it'll throw an error saying, hey, you already made this variable, what are you doing? Okay, So then at the bottom of that for loop, copy paste 45 and 46 and paste them into 53. Yeah. And then paste them into 53 and then get rid of long there also, or it'll throw an error. Okay, yes. So I think this will do what we want it to.
Have we defined the function with vector passed by reference at the top?
Oh, good question.
I think we only did copy. Oh, we did. Okay, cool.
Okay, cool. All right, so now we can call the method in main, like you were talking about. So we call function underscore average underscore timer in the main method.
So
So you can copy the function underscore average underscore timer, just the name, yeah. And then there we go. And then we'll have to pass it a vector. And I don't know how you guys want to do that. Should we just pass it like a big vector with nothing inside? All right, I'm gonna find how to create like an empty vector. I don't know off the top of my head. Okay, I found something. I'll put it in chat. I don't know. Will that work? If you put like that in the function underscore average underscore timer, like parentheses, and then we'll have to pass it a new vector. So yeah. Yeah, and then semicolon, and that it might not like that, but
should we hit run then?
sure, let's see what goes wrong. Oh, do we have to include vector or? Okay.
Okay.
Oh, can you try running it again? It can't hurt. Okay, what does it want? It might want this. It might want, I don't know, this to be online like 62, and then you do it might want you to do that.
Oh, okay, but like before.
Yeah, maybe.
Okay. All right. So what should I do?
Oh, so can you move the standard vector like R1000 and put it on its own line, like above? Yeah, can you move that onto its own line?
Okay.
And I don't know, I'm just guessing.
Outside of main then?
No, inside main, because if it's outside main,
okay.
we won't be able to like use it. Yeah, and then semicolon, and then the name of this variable is R. So inside the parentheses on line 63, just put R. ARR. Yeah, see if that works. So what we're doing is creating a new array with size 1,000. Yeah, okay. Yes, it worked. All right, cool. So that was fast. Okay, can you put an end line on line 47? Yeah. Okay. All right. So I guess we need to run it more than 1,000 times, or it's just way too fast. So can you increase the I is less than to like, I don't know, some big number? Sure. It's still too fast. Okay. What were we supposed to do next? Oh, we
The
want to
random ones.
experiment. Okay, you can copy paste that from code we did last class, actually, because we were filling a vector with random ints. So that'll be easy. Yeah, it's in main, I think. Okay, there we go. It's in main. It's line 27 down to 32. We fill. Yeah.
27, 26.
You can do 26 to 32. 26 is just so it's random, like new random every time.
Okay.
Yeah. And then we'll stick it in main and we'll get rid of ARR. And we'll just do, instead of ARR, you can delete that line. Yeah. And then we can pass in.
If you put as a comment.
Oh, sure. And then you can pass in my underscore vector to the function instead of ARR. Okay, so now we have a big vector, but we're not doing anything with it. So if you run it, oh, you don't need I. We're passing in the whole vector. If you do I, you'll pass in like one part of the vector. Okay, so if you hit run, we should get 0, 0 again, because we're not doing anything, I think. Oh, maybe not. Hey,
Okay.
hey, we got something. Sweet.
That's me typing it.
Wait, you're typing it?
Yeah.
Okay, so can you hit stop? Okay, so it's doing something. I know what the problem. I think it's spending too much time filling my vector. So you see where we put in the size of the vector? Could you make that number smaller? It's 1,000 times 1,000 times 100. Yeah,
Okay.
could you like just make it smaller?
Just which one? The 100, 1,000?
Sure, 1,000 should be good.
So like that.
Yeah, let's see if that's small enough. I think it's taking all the time filling the vector. Yeah, it was. Okay. So can we copy paste the code from yesterday to find the average? Or Tuesday?
Okay.
We're gonna have to do like some kind of math to make it take longer.
So like
So-
this code from,
At the top, probably we're gonna copy the calculating the average. So can you copy like 8 through 12? Yeah, and then we'll just stick it in both of our methods at the top. The by value and the by reference.
this is the by reference. So here,
Yeah, and just paste it in and then return long instead of void.
return one here.
Yeah, return long. Oh, all you have to say is long. So it's a function like signature. So just long.
Okay.
Yeah. And get rid of that return. And then copy, paste it into there too, the other method. It can be identical. And then change void to long again. Okay, now try running it and we'll see what happens.
It's letting me type again.
So,
Oh,
okay, you can hit stop. I know what's going on. Can you scroll up to where we're doing the timing? You see how you have I, or scroll down to function average timer? Can you change line 59 to just be I is less than 1,000? It's gonna be too big. Yeah, all right, now we can run it. And now we can get like an actual like number. Why are they the same? Can you run it
again.
well, can you call srand this time? You were right. So go back to Tuesday's code and copy that srand.
Okay.
That way we can get different numbers every time we run it.
Wait, so what's going on?
And then you put it at the top of main. What?
What's going on? Sorry, I just got back.
Oh, so we basically took all the code from Tuesday, I think, because I'm not very creative. So let's, and we got numbers. So we're getting numbers.
Oh,
So-
but they're like the same. Okay.
Yeah, can you hit run again? So I get different numbers when I do it online, but I'm using different like values for I. Oh, okay,
Hey, there's a different number.
sweet.
Wait,
right.
could you go up real quick?
Yeah.
Just so I can see the.
So reference was faster this time.
Okay. All right, cool. Sometime. Oh, did you? Oh, actually, I guess that doesn't mean. Well, did you divide by? Oh, I just realized it's not going to give you precise time because it's in seconds.
Yeah, can we make it in like milliseconds? That would be a lot better.
I'm sure there is a way. Okay,
Okay,
time
I will-
returns the number of seconds. Yeah, okay. Oof.
Did you find a way?
No, I'm just making sure it returns a number of seconds. There's no formatting for this.
Oh, I found something.
Yeah, that's
That's interesting. Did you type something? So I think we're getting seconds.
I mean, yeah, definitely, right?
Yeah.
Definitely getting seconds.
So dividing by 1,000 will just give us like 0.
Yeah. The data itself is in seconds. That's the issue, right?
Yeah.
I did find something using the chrono library. If we're in C, if this covers, I don't know. If you go up to language and you hit C++ 11.
Hey, I'm back.
Hey, Professor.
Do you guys need any help, or are you guys happy figuring out
Or 14, I guess.
stuff on your own?
14.
We keep
We're
getting
just,
seconds.
yeah, so our data that's coming back is coming back in precise seconds since.
Yes. Yeah, you're using time. You have to get it back in seconds, right? You're
Right,
not using
so-
any, you're not using the finer, the nanosecond timer and things like that, right? Because that's a pain. You got to use other structures. Easiest way is to just use time and measure in seconds for, let's say, 10,000 invocations, right? Then if you divide by 10,000, then the 10,000 invocations will give you, 25 seconds. 25 seconds you can measure using time. And if you divide 25 seconds divided by 10,000 is going to give you what? 2.5 milliseconds per invocation. Yes, we can do that now.
Oh, I see. So not long, we'd use double to divide by.
Yeah. When you divide, you do the double. Yes. When you divide, you
Oh.
got to use double. Do you want to do it now? Do you want me to talk you through it, or are you guys happy to do it on your own?
Could you talk us through it?
Yeah, sure. Okay. All right. Let's get to the screen. Let me take a really quick look at what the code is now, and maybe we can, and I can, maybe suggest some alternate practices which may be different, so that you get a different view of the same thing. All right, let's take a look. Go up more. Let's take a look at functions. Two functions. You got the two empty functions, right? The functions should be absolutely empty because we're doing our control, right?
We did empty and we got like 0 seconds.
Oh, all right. So yes, it's important. It's important. I'm glad you got 0 seconds, because it'll take you a little while to figure out why you got 0 seconds for both, no matter how big the size is, right? However big your vector is, whether it's 10 elements or 100 elements or 100 million elements, right? If the vector is empty, it doesn't make any difference whether you pass by reference or copy, because it doesn't have to copy all of those elements, because the vector is empty, it's 0, right? It can basically send junk over. Doesn't matter what it is. So whether it's copy or reference, there's not a huge deal of overhead. Anyway, I don't think it can even make sense to you now, right? But you'll see it happen, and you'll figure out the answer yourself in just a few lectures from now, right? We'll try it. Okay. So for now, yeah, let's make it. Let's get rid of the average calculation, right? And put it back to void. Oh, I see. I can see why you changed it to long and put the thing in there, because you wanted it to take longer, so that it'll be measurable with time. Yes.
Yeah,
you made it. Yeah, you made it take. Yeah, it's very common, right? So change that to void. Change that to void. I'll show you how to do it with the old stuff, right? Change that to void. Change the long to void, right? And then get rid of the average calculation and all, and just return 0.
Okay.
Just get rid of the average calculation and everything. Yeah, and return 0. Return 0, and I'll show you how to make it work using that. Right? It's also possible to make, right? But this way we have minimal external contamination. We're measuring exactly what we want to do: ampersand and no ampersand. Okay, exactly same function but different name, and then no ampersand. Right? A function with no, not that. One. I think it's up there. No, above that. Pass by copy. So you need the same thing for pass by reference with the ampersand. Where's your pass by reference? Yeah, exactly the same thing. Get rid of everything. Return 0, and then change the long to a void. Yeah, and then void, right? Now this has an ampersand, right? Okay, now I think you guys wrote some other functions. Let's let's actually use those functions. Okay, I think where's the function that you were going further down. I saw a couple of functions you wrote. We can actually use those. Oh yeah, there you go. Function average timer. Okay, yeah, let's do that. Okay, function average timer. Yeah, that's great. Actually, just indent everything, okay? Because it's a function, it needs to be indented in, right? Indent the body, indent the body. No, indent the body of the function, not yeah. Four spaces in. Start it long. 4 spaces in. All right. Start time equals time. Now that's great. Okay. Next line. What? Yeah.
Yeah.
Next line. Put a blank line before the declaration and the body of the. So yeah, blank line, because for basically starts the logic. It should be part of the blank line before that. Next paragraph. Blank line there.
Got it.
Tab. I don't know. What are you doing? Just tab in front of the 40. Tab in front of the 4. Tab in front of the 4. Tab. Okay. Now what's go to the end. What is that thing at the end with between the curly braces? What's that thing between the curly braces? Oh, I see. You're calling it 1,000 times there. Okay. All right. All right. The braces are all messed up because of the indentation online GDB. Get rid of the braces because you're just calling it 1,000 times, right? So get rid of the braces. That one and the one on line 46. Get rid of it. All right. All right. Now indent this function in because it's part of the for loop. Right. And then at the top, after long start time equals on line 42, hit enter after that. Enter after that. All right, there. That's fine.
Oh, after.
No, that's fine. It doesn't matter. I just want one more variable. Okay. Just say const int up there. One line up. The const size t const. Let's make it size t. Size underscore t. Num underscore times, right? Num underscore times, all caps. Num underscore times. Space. N times or num times. Yeah, it's got to be all caps because it's a const, right? That's a convention I find useful to follow. All caps, num times or n times or whatever you want to call it. It should be all caps. Yeah, times equals space equals. And then you can say let's say 100,000 times. No, let's say 10,000 times. 10 times 1,000. 10 times 1,000 semicolon and then 10 times 1,000. 10 space times space 1,000 semicolon. Okay, and in your for loop, what you're going to do is basically change the 1,000 into num times. And it's num times, not num time. Okay, I think it's. Because it's the number of times you're going to call it, not the, yeah. All right, now you go to the last, after the for loop and hit enter. Yeah, enter.
After for loop?
Yeah, enter there. No, not there, after the body of the for loop, I'm sorry, not after the for statement, right? After the body of the for loop, enter, yeah. Enter, one more enter, and then backspace, get rid of the indent. Now what we're going to do is time per run. So you're going to say double time per run, double. Madison, just hang on for 10 seconds, okay? Because we're going to you can look at the code later, right? Just this is the key part that you guys were missing, I think. Double time space time underscore per underscore invocation. Time underscore per invocation invocation VOCATION invocation INVOCATION, right? It's invocation, yeah. Invocation equals, and then within parentheses you want to say time null, what you have on the time null. Yeah, time null null, null. That's going to give you a current time. Yeah, time, open parentheses, null, close parentheses, like you have on line 43. Yeah, and then minus. Great, thank you. All right, and then minus.
Okay.
Minus, space, minus. Yeah, this is space. It's nicer. Space. All right, and then start time. Yeah, and then outside of the parentheses, go outside of the parentheses. Yeah, space, divide, space, divide. Yeah, Agnes, okay. All right, I think Agnes is, yeah, and most of you probably know what we're doing now. Divide by num times. Divide, divide.
Oh, divide.
Divide. Num times. All right. Now, here is a catch, okay? Now, many people, there's a bug that many people might introduce unwittingly. Num times is an integer data type. It is unsigned long. Yes? Are you guys all here? Because it's an important point. You might actually get bitten by this. Okay. Some of you have gone, but it's an important point. Okay. Just pass it on to the rest. It's an integer. Long is an integer. You're dividing times return value, which is an integer, by another integer. And then, you know, the fractional part will get cut off. And if it's 25 divided by 1,000, you're not going to get 0.025 or something like that. You'll get 0. Okay. So to account for that, you either have to typecast the denominator num times to be a double, or we can do something easier. Actually, let's typecast it. That's better. Okay. Just say double within parentheses in front of num times. Double within parentheses in front of num times, right there on the same line. Just say double within parentheses.
Yeah, yeah.
Not there. In front of num times.
In front.
In front. Yeah, there you go. Within. So what that says is that, you know, I'll take num times, which is an integer. Long is an integer, right? But I don't want to divide one integer by another because I'll lose the fractional part. So I'm going to convert num times to a double and then divide an integer by a double, which will give me a double. So 25 divided by 100 is 0.25, not 0. Now, this is a very important point. This is a very important point. Lots of people miss it because then, you know, you'll lose a lot of precision. Is everybody okay with this so far? Or you want a semicolon at the end? You want to put a semicolon? Put a semicolon at the end of the line, right?
Professor, I have a quick question.
Conventionally, people also have a space after the double closing parentheses and num times, right? So it looks nicer that way. Put a space before num times. All right. Now on the next line, you can just return time per invocation and close the function. That's it. On the next line, just say return. On the next line, you can say return time per invocation. And we don't do the cout here because, you know, you can just return the value and then main could do the cout. Don't do couts in called functions, right? Unless necessary. So you're going to do void, change the void return type of this function to double return type. Yeah, enter, and close the parenthesis and close the brace, close the curly brace, enter. Close curly brace. Yeah, and then at the top, not at the very top, at the where the function is declared, a few lines up, line 40 or something. Line 41, turn the void into a double. Okay, now is everybody clear on what we just did? Now the same thing has to be done also for the other one. Function average timer, you can pass it up. Yeah, you can also pass that by reference, right? You have to have a function average. I see you're passing a vector. Oh, what are you doing here? You have a function average timer. And I see. Yeah. Now I remember. Well, some of you were saying, oh, we need a function that takes another function as a parameter, right? You got to pass a function point parameter. That is nasty stuff. We don't want to go down that route. In fact, C++ provides a much nicer way to pass functions as parameters called functors, right? We'll cover that in CS2B and 2C. For now, what we'll do is just hard code two functions, right? Let's just say this function is going to be, change that function average timer, change the name of the function to time, change the name of the function to time underscore, I don't know, what it was, time function called with ref param. time function called with ref param. All right, make that called param, P-A-R-A-M, P-A-R-A-M, and P-A-R-A-M. Okay, all right, now it's going to take a vector pass by copy here also. Now let's make that, make it so, you know, it's not going to take a vector parameter here. We don't want to, right? What we're going to do is construct the vector here. Okay, just get rid of the vector parameter. Just get rid of the vector parameter right there. And then go to your main, and copy the place where you create the vector. And let's bring it in here. Yeah, get rid of that.
Get rid of this.
Yeah, get rid of that. And go to your main. Where's your main method? Oh, it's up there. Can you just copy main and take it all the way to the end? Because, you know, otherwise we're going to call functions which are declared later. And so just copy main and take it all the way to the bottom of the file. Is it at the bottom now?
Yeah, it's at the bottom, yeah.
All right, great. Now get rid of the srand. We don't care about srand also, no, right? Because right now we don't care about the specific values. We're just trying to see, this is the size of the vector. I don't know what the values are. This is the size of the vector. Is it taking longer or shorter, right? Just copy line 71, cut line 71 to 76. Cut line 71 to 76. Cut it. Right, now put that in your the function that you just created, time something, right? You just created a function called time. Further up.
Okay. Oh, you want me to copy
where is
it?
the function that you just created? You just create a function called time vector. Yeah.
Yeah. So.
Right. So after your long, after that, after line 43, press enter. Enter. One more time. Paste. Now, what happened to your for and everything?
Yeah, paste.
What happened to the for loop and everything? You cut it, right? Didn't you cut it?
Yeah.
Where is it?
I deleted it. Which one? This one?
Yeah, the whole thing. Line 71 to 76. You want to cut line 71 to 76, all of it. Okay, cut.
Okay. Right.
Professor, I have a quick question.
Well, one sec, Neil. Because I think so you'll forget this thing, right? Okay, go. Where is the function that you just created? Where is the function that you just? Hey, so I'm totally lost here. What are you doing? Because your screen is jumping by and we're out of sync. What are you doing?
I think you're looking for the timer function that you just called. Oh, there.
I mean, yeah, this one, yeah. The double time function called the ref param.
Oh, good. All right, all right. Long start.
Yeah, and then I pasted that thing down there.
No, it's not done. Where is in your main? Where is your? Oh, I see. You pasted it down there. It should be pasted inside the function. I'm sorry. Okay, I didn't see, and the font size is missing. It should be pasted inside the function, right? So go. Where is that? Where is the? All right, cut that. Wherever the line 71 is. Put it back in main, and I'll walk you through every step. Okay, don't jump steps here, and I'll make sure it's all good. Okay, right, cut it. Now go inside your function to line. No, don't skip ahead, Soe. Okay, yes, go inside your function to line 44.
Okay.
Enter. Okay, paste. Right. So this is what I meant when move this code into that function means that's what it usually means. Okay, is that good? So everybody, right? So when we move code from one function to another, And you're going to be doing hundreds of times, right? Many times. What you're going to do is cut from here, put another function, cut from here, and then move things back and forth. And you'll find that you'll do a lot of refactoring like this. Okay, here, let's go back into your function. All right, now create a loop.
In the function, okay.
Where is your function? Okay, indent it in. Every time you paste something, just indent it in and make sure it line 45. Okay, good. And in fact, join up that declaration with the previous thing. Yeah, thanks. Join up the declaration 45 with 43 so that the blank line is missing. Yeah. No, I think the indentation is messed up. Get rid of 44. Get rid of 44. Yeah, okay. Now I think 46 is too far indented. Bring it back one level. 46, bring it back one level.
Okay.
Okay. Now you're going to say, and bring that back. Yeah, re-indent all of those. One back, one level back. Okay, good. All right. Now, where you have const size t num times, you can also have another const. You can triple click on the line, paste it one more time. We'll create a vector size also here, right here. Okay. So you say const size t, vector size equals 10,000 right there. Right on line 42, go to the line end of line 42 and hit enter. Hit enter at the end of line 42. Enter. Right, Neil. I'll come back to you in 1 sec. Okay, we're almost done here. So
All right.
const size t, const space size t, vec underscore size, all uppercase. No, yes, space. Thank you. Sorry. Okay, space vec underscore size.
Okay.
Space vec underscore size, all uppercase. Because it's const, yeah.
All uppercase.
Underscore size equals. So let's say 10. Let's say also 10,000, right? Let's say 10,000. 10 times 1,000, or let's say 100 times 1,000. 100 times. Let's say 100,000. 100,000 is doable on this computer, on this online computer. Right. Times 1,000. Okay. All right. Great. Now, put a semicolon there. Now, where you say 100 times 100 on line 45, turn that into vec underscore size.
Yeah.
Yeah, is everybody together with me so far? Okay, right. Now at this point, since you've sized the vector and you haven't started, and you start time, right? Get long start time. Triple click on line 44 and copy it. Cut it. Triple click on line 44 and cut it. Command X. All right. Now move all the way to line 50 and hit enter. Enter.
50.
Okay. Now put a comment there. Put a comment there saying. Right. Yeah. Now this is for future students and also notes for you, right? Only start the timer at this point after the vector has been filled in. Okay, because many people will start the timer before you even fill the vector. You don't want filling the vector to interfere with the time taken to measure the whole thing, right? So you only start the timer here, right? Now on the next line, you paste what you just cut. All right, on the next line. Yeah. Is everybody together with me? This is a very important point, okay? And that's the reason why we're spending some time. Paste, Command V. Great, okay. Now get rid of the blank lines before and after and adjust the indentation so it's correct. All right, now, there you go. Right, now, the thing to understand here really is that we're starting the timing, not right at the beginning, where we're starting the timing only at the time when we're ready to start calling the function 1,000,000 times. And we stop the timing as soon as we finish calling the function 1,000,000 times. Or is everybody okay with that? Because we could have started the timer anytime, right? But there's no point in starting the timer when we're doing other housekeeping stuff. Yes or no? This is the core of measurement. You're going to be doing measurements of code a lot of times, but the way to correctly measure things is to bring the timers, the measurement points as close as possible to what you want to measure. Yes? So if you want to measure the thickness of this, I want to put the ruler like here, the pointers here. I don't want to measure that. Yeah. And then subtract that, and that's a mess. Is everybody okay? I don't know, nobody's answering. Neil, you had a question.
Yeah, sorry, I understand. Sorry, I didn't say that. Yeah,
No,
I
you
got
had
it.
a question before. I said I'll come back to you.
Yeah. So when you were talking about typecasting on line 56 num times to a double, is there an operator instead of the, I know that I think the single.
No. Like, yeah, I know. In certain languages, you have a separate operator for floating point division and non-floating division.
Yeah,
Yeah?
I was gonna ask, is there an operator like that for single? No.
No,
Okay.
no. So in fact, it makes total sense to have different operators, right? Because it's two different algorithms. Floating division is different from integer division.
Right.
Yeah, but in C++, what we decided to do was just use the same operator because it is intuitive, right? Because that's what we learn in school, right?
Okay.
And then we say, let the computer do the work of disambiguating which one is needed at any particular point.
Okay, so you mentioned an alternative method instead of typecasting. Could you
Yeah,
give
so the alternative method is to basically, instead of saying num times is a long or a size t, we say num times is a double.
Okay, got it.
Yeah, but that I didn't do that because num times intuitively is a number, is an ordinal. Is right. Num times cannot be a double.
Right.
So the naming does not work. That's why I said let's do the typecast instead of
Typecast is better. Got it. Okay. Thanks.
All right, good. So is everybody okay with what we've done so far? Hey, well, why is all that code up by the margin itself on line 65, and why is all that out there? Get rid of that. Get rid of that. Right? Cut it. Maybe we'll put it inside of cut that code. Let's put it inside main. So we'll leave this code in a good place so that for future students, right? So cut from line 62 to 73. 62 to 73. Cut it. Cut it for now. Cut it. All right. Now in main, what we want to do is in your main, you want to say go to your main, and you want to say on line 61, hit enter at the end of line 61. Yeah, right. Now you want to say double time per invocation, double space. Time per invocation, and then underscore pass by reference, or pass by reference, underscore pass underscore by reference, when passed by reference, or whatever it is. You just need to say this variable equals, and then you call your function, right? Yeah, pass by ref equals, and then whatever that function was that you created. What was the function you created? Yeah, right here on line 40, time function called with reference. Yeah, okay. Triple click that and just paste it there. Yeah, that one.
The whole line is just the time function called.
We want to call that function, so you can just go to.
Yeah.
Yeah. I open, close.
Okay.
Yeah, open, close, and then semicolon.
Open what?
Open, close parentheses and semicolon. Semicolon. All right. Now you want to create another function just like this, except when it calls that other function, it calls function with vect passed by reference. Oh, this one is copy. We only did the copy. So what this function should be called passed by copy, not passed by reference, right? The one you created on line 46 should be called passed by. Or you can change this to pass by ref, right? Inside the function. This one is passed by ref, right? So you can say this is on line 54, you say a function with vect passed by ref, not copy. On line 54, change the word copy. No, just change the word copy to ref. Yeah, because that's what we're trying to time. Yes or no? Now you need another function just like this, where it's called time function called by copy, and then this should be called by copy, and then in your main you can call that and find out, and then you can do a cout. In main you can do a cout. All right, so hit enter after line 63, and we'll do a to-do item for you guys, right? Enter after line 63. One more blank line.
Oh no.
And then open a comment, and then say to do. Right, this is for you guys. to do. Yeah, colon, and then all right. Now you say do something, do a similar measurement for time function called with copy param, right? And which you're going to have.
Called
By the way,
with-
line 63 should be deleted, right? We shouldn't have line 63 at all. That's a holdover. Yeah, copy param, right? Which you need to create. You need to create that function. It doesn't exist right now, right? And then go to the next line. Go to the next line. No, don't scroll past like that, because it's very hard to read your code. Yeah, go on to the next line, which you need to create. Okay, all right. And then after that line, hit enter. 65, end of 65. Go to end of 65, hit enter one more time, and then another to do,
Okay.
another to do, and you can say now in main you can print out the 2 times. Okay, do a cout and do a cout here to print out. Do a cout here to print how long each method took. Do a cout here, right? Do a cout. Do a cout here to print how long each method took. All right, so that's basically it. And then, yeah, enter. So you have to fill in these 2 to-dos, and then you also have to do the other to-do, which is basically copy this entire function and make it call. Now, what happens if the granularity is basically it's saying it's all returning 0 or the same, right? Then I think the way to check this is to simply go into your function, these 2 functions, and say, I'll keep the vector size. Don't change the vector size, because the vector size, I think 100,000 or 10,000, whatever it is fine. But the number of times you can change it from 10. Let's say I'm going to change num times to 1,000, 10,000, right? I don't think you can do more than 1,000 times, right? Already 1,000 with a vector of size 100,000 is, we're talking about 100 billion, right? So it's 10 gigabytes of bytes it needs to process. Maybe, so you got to play around with these numbers, right? You got to play around with these numbers so that you get reasonable times back. I'm happy to basically sit around and try this with you now, but I am cognizant of the fact that some of you need to go. But if you want to stick around, I'm happy. It'll take you like 10 more minutes to wrap this up and run it, right? The risk in doing that is that I will be eating your lunch, right? Because this is really fun stuff to do. If you want to do it, do it. You can either do it in your own time or you can do it now, right? It's past class time. Those of you who don't need to go away, do it. I'll be around. You can call out to me to come and help you, right? But this is the fun part. When it's done, you can share it on Reddit, right? And say, oh, you can share it like this too. And
Yeah, real quick, speaking of sharing, so once you're done, can you just hit that share and then post it on Reddit? Or if you don't want
No, you got to get the URL. When you hit the share, it'll give you a URL.
Yeah, I know. If you don't want to post on Reddit, could you just put it in Discord? Either way.
The problem is, yeah, you won't get any points for getting it.
You guys,
Discord. Yeah,
Yeah,
don't
you
put
can
it in
post it.
Discord,
You can post
okay?
it in Reddit. Just make sure you send it somewhere so that everyone else has it. Sorry. Go.
Yeah.
okay, but are you guys gonna keep working on it? Like Hiram and Neil, are you guys gonna keep working on it?
I'm definitely gonna look at it, and because there's a lot of stuff that I don't understand, and I'm probably gonna like do something with it. But yeah.
Hey, do the discussions on
Gotcha.
Reddit,
But I'm gonna
okay?
go right now because I gotta go. I have another class.
By the way,
Yeah.
stay off Discord and Slack, guys, okay? Because nobody's getting any points for those discussions. And Reddit will be much better for you to come back, and others, future students, if they want to look at some of your discussions, they can see it if it's on
Got
Discord.
it.
Right?
Yeah. Sorry. Yeah. Post on
Do
Reddit.
it on Reddit.
Got it.
All right, so
Okay.
I hope you guys are good. If you guys want to go on and complete this, I'm happy to do it now, right? Or you guys can do it, I can stick around. What do
I
you
gotta
want?
head out. Thank you though. Thanks, guys.
All right, good.
Bye.
We'll pick it up again on Tuesday, okay? We'll just wrap it up on Tuesday. We'll do the measurements. We'll also do this Google spreadsheet thing, right? Because next week is basically a review. We can complete this, all right? Just keep this. Keep the URL, post it on Reddit, share it. Next week, we'll come back to this and pick it up. Yeah? Was this class useful to you guys? Did you
Okay.
guys pick up anything new?
Yeah.
Yeah?
Yeah.
Thank you.
Can I talk to you for a bit?
Yeah, sure. Fernando, hang around. Yeah, I also wanted to talk to you. So, hey, thank you so much for driving today, okay?
Yep.
You did a great job. Great
Yeah,
job.
I need to go. Yeah.
All right, thanks. All righty. Fernando, you want to talk to me?
Yeah.
All right. What's up? What's up?
You know how I promised you I was gonna send you the quest by yesterday?
Yeah.
It's been really I haven't, to be honest, I'm gonna be honest with you, I haven't started quest 4. The thing is that I had a test on Wednesday
You
and
don't have to finish quest 4 by yesterday. Who said you have to finish quest 4 by yesterday?
oh no, you wanted quest 4 by week 5, right? By beginning of week 5.
No, it's end of week 5. That's basically, by Monday next week.
Oh, so all quests are due by Monday next week?
Not all, only 1 to 4.
Oh, okay.
Yeah, you're good, Fernando, right? Basically here, if you have made any progress at all in quest number 4, right?
Yeah.
By Monday, and you're not able to submit it, just email me and say you need a bit more time, okay?
Oh, okay. So I thought it was this Monday that we're
No. Even if it's this Monday, you can always email me if you've been working on it.
Oh, okay.
Right?
Okay.
The only people I don't give extensions to are people who basically just start with quest number 1 tomorrow.
Oh, okay. Okay, Mr. Nand. Oh, I
All
thought it
right,
was,
no worries, Fernando. You
thought
see,
it was-
who has your Xbox? You or your brother?
I don't have an Xbox.
PS2. You said you gave it to your brother.
Yeah, my brother.
Okay, all right, let him have it.
All right, Mr. Nand. I was scared. I thought it was due all 1 to 4. I thought it was due this Monday.
Yeah, no worries. Don't worry. Okay.
Okay, so I'll send it to you by this upcoming Monday, right? All 1
You
to
don't have
4.
to send it to me. Just submit it. Submit everything, and if you need more time, just email me.
Okay, thank you, Mr. Nand.
All right. Okay.
All right.
No worries. Bye.
Bye.
Hi, Ram. What's up?
Well, I was doing quest. So if I want to have more decimal points on something, then double can provide. What can I do?
Yeah. Well, you can only have as many decimal points as double provides. I don't think there's. Oh, there is a double precision, right? I think there's
Double?
Yeah.
Okay.
I think there's a double now.
Okay, wow.
007, like. But I think double is pretty good for most practical purposes. But if you want to, so the thing is, internally in the computer, it is stored with huge numbers of decimal points, right? But what you see on screen is very different. What you see is very different from what's inside. So what you see is controllable. You can say using iOS :SETW. I think that's what you can just Google it, right? There's a way in which before that's in the cout where you say cout double less than X to print double quantity X.
Okay.
Right? You say cout double less than some magic numbers, magic tokens here, like iOS :SETW and 7.5 or some crazy formatting information there, and then double less than X, then X will come out in the format that you want.
So wait, double actually has like a lot of decimal points? So double has like
internally, if you store the number pi internally,
right.
It is going to be stored internally as the maximum number of digits you can represent within those 8 bytes. So it may be 3.14159265358. Okay, that's all I remember anyway. Hey, maybe that's the internal representation.
Okay.
That's how much you can represent in 8 bits of accuracy. When you ask the system to print out pi, it's not going to print 3.1415, right? It'll print 3.
What if I use toString?
toString or whatever it is.
Okay,
right?
so
if you use these basic methods to say, here's a double, print it out. It's just going to do some, default formatting. Say, oh, it's 3.142. It won't give you any control.
Okay.
Right? If you want to control the number of decimals and all these things, before you send double less than pi to cout, you're going to have to send some control characters. Whatever is coming next, I need to be printed like this, not like this.
Okay.
You need to send the control information, yes?
Yeah.
Okay.
Honestly, this is for Quest 4's GP terms again.
Yeah. So you can I think in module number, I don't know, it's every single C++ textbook has ways in which you can format numerical output. You just go to Google, C++ format numerical output. We'll just, top answers on Stack Overflow will usually be good, right? I think Michael Loser modules also do a very, very good job on explaining this.
Look at this.
I think it is, maybe it's week three modules, right? Check in there. There's also examples in there.
Okay.
Yeah.
Because yeah,
It's
it wants,
very straightforward and easy. So yeah.
Yeah.
Do it.
great. It wanted 9 decimal points and I was freaking out. 'cause
Actually,
I
you know
couldn't
what?
use
Yeah, you should ask this when other students are there too. Now you have to post in Reddit saying, for those of you who are stuck with formatting, this is how you can
Okay,
do it.
yeah.
Yeah, to do it in
Okay,
Reddit.
I'll figure it out.
And also the other thing I wanted to say in class, and I unfortunately I didn't, was those of you who are stuck with information, I don't know what to post on Reddit. You can basically just post a tip sheet for quests that you've already finished and say tips for quest number 1. Right? These are places where you could get stuck, or these are places where I got stuck, and this is how I got out of it. Right? Tips. Lots of students have done that, and that's a guaranteed way to get a point for that quest. A participation point for that quest because it's useful, right?
Yeah.
So those are that. Yeah, pass that information also on to other students and get them to do it on Reddit and not Discord because that is not helping other people. Thanks. All right, I'm going to be around. Just
also
reach out to me, guys. Right?
Also, really quickly, I did a post on Reddit and you said like don't look up stuff, right?
Oh, you I'm sorry, you did a post on Reddit?
I did a post on Reddit and then you responded to it with like don't look up stuff, right?
I said that?
Yeah, you said don't look up stuff that's already been done. It was a discussion about like how to do a sorting question.
Oh, yeah. No. I shouldn't have said it like that. What I meant was don't look it up before you find the answer yourself, or before you've given it a fair shot.
Okay.
Because
So
the
yeah,
temptation is
okay.
high. The temptation is high to basically in math.
Just immediately go for it, yeah.
Yeah, in math, and that was one of the disadvantages of a Reddit forum is that people can look up solutions.
Yeah. So should I avoid? Because in that situation, I actually just had studied that like 2 years ago or something. So I just remembered something. So should
I'm
I like
sure
avoid?
you're fine, Hiram. Yeah, because you're naturally interested in programming and you try and find out these things. I think I'm more concerned about some other students who may not be as familiar with programming, who just came into CS2A, and for them the temptation will be harder to resist, to just pick up the answer, put it there, and not think about it.
Yeah. Okay. Thanks.
All right. No worries. All right. Take it easy. I'll see you next week on Tuesday.